activities, U.S. initiatives, but these also, they're going to spill over because there's a lot of connectivity with other countries in all of this. So we're going to start with Mike McPhaden, who's going to talk about the status and plans of the Indian Ocean Observing System and RAMA.
Okay, thank you, Raleigh. This will be a brief introduction to INDOOS. INDOOS is the Indian Ocean Observing System. It's the Indian Ocean component of GOOS, the Global Ocean Observing System, and it's comprised of a constellation of Earth-observing satellites to provide measurements of essential ocean variables such as sea surface temperature, surface height, surface wind, and others. And it's complemented by a collection of in situ measurement platforms shown schematically here. And these platforms include a moored buoy array we call RAMA, that's the green squares, a collection of ship of opportunity XBT lines, a network of surface circulation drifters, and a network of Argo profiling floats. And we should add to this the Ghost Ship program, which even though it measures in this region only once every 10 or 20 years, still provides essential information about the deep ocean in particular. The purpose of INDOOS is to provide sustained high-quality oceanographic and marine meteorological measurements to support knowledge-based decision-making through improved scientific understanding, weather and climate forecasts, and environmental assessments. The INDOOS was designed in 2004 by the Clavar-Goose Indian Ocean Panel. Up to that point, there was not a coordinated international effort to make sustained measurements in this region. And so, hence this design. It is primarily, at least initially, conceived of as something to study physical oceanography, ocean-atmosphere interaction, and climate variability. We'll see that this is expanding, this remit, shortly. It was designed to be basin scale so we could observe the evolution of phenomena like the monsoons, seasonal monsoons, the interannual Indian Ocean dipole, intraseasonal Madden-Julian oscillation, et cetera. But it is complemented by some regional observing system elements like the integrated marine observing system around Australia, measurements of the Indonesian through flow, measurements of the Agulhas, Madagascar Channel, and East Africa. And finally, it supports and benefits from process-oriented studies, and a number of them are shown here. Some of these have already taken place, like Seren in the Seychelles-Chagos Thermocline Ridge region, Assyria in the Bay of Bengal, Cindy Dynamo to study the Madden-Julian oscillation. Some are upcoming, like the ONR-funded NASCAR and Mesobob and the Arabian Sea and Bay of Bengal, respectively, Year of the Maritime Continent that Jidong will talk about, and we've already heard about the Upwelling Initiative in the Eastern Basin, IORI. INDOOS supports these by providing a large-scale, long-term context in which to interpret the measurements. INDOOS benefits because these process studies provide test beds for new technologies and also inform about phenomena that maybe we need to incorporate into the sustained observing system and aren't doing yet. I'm not going to give you a comprehensive overview of the status. I'll just make a few comments, though. This is an interesting page, the Observing System Monitoring Center that is maintained by NOAA. You can go on this page. It's a menu-driven page. You can pick a particular period. I just picked the last 2 weeks. I picked the entire global ocean, and I picked all the platforms in the Ocean Observing System, drifting buoys, ship measurements, moored buoys, Argo, and other measurements. You can make a plot like this, and you can also separate this out by individual observing platforms. You can change the period that you're interested in, and you can also look at national contributions. You can color code this by the nations that are contributing. That's kind of a centralized status, a centralized place where you can go for status. Each of the observing system components themselves maintain their own web pages and data sets, so you can go and look at the status and the history of the development of these observing systems. And here are three. Argo, in the past 10 years or so, Argo has a target of 450 floats north of 40 North. It actually exceeds that now, 576 Argo floats, plus 48 which are biogeochemistry floats. The drifting buoy array has a target of 200 drifters north of 40 North. This shows the map of the current distribution. It's about 90% of the way there. so it's about 180 of them out there. RAMA has a target of 46 moorings. This shows its development over the past 10 or 15 years or so. It's about 80% complete as well. Comment about Ghost Ship. As I mentioned, Ghost Ship is measuring in this region only once every 10 years or so. Actually, I-7 North was last measured in 1995. So the Round Brown is going to the Indian Ocean in February, April 2018, a first priority of which is to maintain this Ghost Ship line here, but it will also do some RAMA servicing on a transit from Goa to Darwin, and then it will end with years of maritime continent work in the Indonesian seas. A lot has happened since INDUS was first established 10 or 15 years ago. We certainly have learned a lot more about the Indian Ocean, and that has driven, that new understanding has driven a reorientation of our scientific priorities. We've also seen that new technologies are available that could be incorporated into INDUS, and there are new programmatic opportunities, one of which has brought us here today, which is the Second International Indian Ocean Expedition. And so as a result of that, the Clive R. Goose Indian Ocean Panel has initiated an international review of INDUS. And the terms of reference of this review are to make actionable recommendations for priority observing system components going forward, including pilot studies and new technologies, provide the justification for these recommendations by reviewing the current status of INDUS, articulating the scientific and operational drivers, and identifying the essential oceanographic variables that address these drivers. And this review is already underway, as I'll show you in a few minutes, and it will culminate next year at a conference in Mumbai, Indonesia. So science drivers are mentioned here. The Indian Ocean Panel has identified 14 of them, and they are listed here. You will notice that some of the traditional ones are here, interseasonal variability, interannual variability, etc. But there are some new ones, too, as we have expanded the remit of INDUS. Carbon cycle, ocean acidification, biogeochemistry, ecosystems, oxygen variability. So it's becoming much more of an interdisciplinary focus, and many of these actually align with those of IIOE2. Each one of these topic areas has a specific white paper devoted to it, and you can go to this web page to look at those. Write that down quickly, that one there. There are also operational drivers, and these are improvement of seasonal prediction, improvement of subseasonal to seasonal, or what we call S2S prediction, improvement of surface fluxes, and ocean reanalyses. And again, each one of these topics has a white paper on this Google Drive. And then finally, these operational and science drivers feed into a discussion of what the design should be. And so from this, we have a number of white papers that look at how those requirements affect different observing system platforms. And here I've actually listed the lead authors on these various papers. Again, you can find white papers on these topics all in the same Google Drive. And without going into great detail, I will just point out, you can see some of the changes relative to the original design just in the title of these. For example, with Argo, now we're talking about deep Argo to measure heat content variations below 2,000 meters. Biogeochemical Argo to look at biogeochemical processes in the region. New technologies, including gliders and inverted echo sounders, which are particularly valuable for examining western boundary current variations that are not accessible to the technologies we have at present. And the last slide is the timeline for this review. All these white papers now have been written and are on that Google Drive. So if you're interested, and many of you in the room are actually already involved in this process, I mean, this is a good time for the IIOE2 community to feed into this process by looking at some of these white papers and commenting on them. From that collection, there's about 26 or 27. The Indian Ocean Panel is going to produce a synthesis white paper. It was supposed to be done several weeks ago, and Lisa, I know, is the co-chair of this committee. It's been delayed for several reasons, but we're close to having that. That paper will eventually be sent to a panel of experts, outside experts, for review. And then in March of next year in Mumbai, we'll have the review conference where this paper will be discussed by the review panel, and there'll be some iteration with the Indian Ocean panel, and we'll come up with a final tentative design for what we'll call the next generation INDUS. So that's it. Thank you, Raleigh.
Thank you, Mike. So we have time for a couple of questions for Mike about INDUS, RAMA.
Okay.
Oh, there we go.
Really quick, because I'm not a geochemist, but I was wondering where geotraces falls in any of this.
We'll be reporting on geotraces a little later. So.
Yeah.
Great question. Anything else? Okay, thanks, Mike.
Thank you.
Okay, next short presentation is by Lisa Gill, and she's going to give us an overview of status and plans for research in the subtropical and southwest of the Indian Ocean.
Oh, I'm sorry. I was saving this for questions.